And we will come to this. So how this dust particles suspended in the air? So you can see dust particles interesting. And sometimes moisture particles, moisture also, we won't say particles, but moisture also can be suspended in there. Moisture. See what air does is moisture also can be suspended in there. Means air carries moisture as well. It's interesting. Moisture particles. So instead of suspended, we call it this way. Air can hold moisture. Moisture means water vapor. Okay, water vapor. Up to some extent. There's a limit for air to hold water vapor. Up to some extent. Not to say you can add whatever you need. Okay, but air has its own water retention or water holding capacity. Okay. Air has its own water holding capacity. Moisture, okay. So instead of holding, I take the word retention capacity. Okay. Own moisture retention capacity. Air has. Interesting, that's it is natural. Okay, it is natural. Okay. Yeah, that is natural. What is difficult one? It is moisture, let's say, yeah, naturally contains moisture. So that's how we say. So if we need to have dry air, we have to remove moisture. Okay. So if we need to have dry air, we have to remove the moisture. If we need to have more moisture, we have to add moisture. So this moisture in air is something natural. But for our case, we have to control moisture in air some case by adding moisture or by removing moisture. But understanding moisture in air is very important. Please don't send the attendance now. Okay. සිංහලෙන් කියවට තේරෙන්නේ නැහැ නේ. සිංහලෙන් නෙවෙයි කිව්වොත් හරි ඕකේ. මම කියන්නේ ඉංග්‍රීසියෙන් කියවට තේරෙන්නේ නැතුව ඒක. Attendance moisture in air. You must have a good sense of this. Moisture in air. And this is a big topic, even though we are talking in so simple way. So moisture in air is somewhat a bigger topic, but we have to have a solid start on this. Okay. So that's the part. So later you can learn a lot, but have a very good basis on this. Yeah. Feel good about recognizing this natural phenomena. Yeah. So same like dust particles. Interesting. Okay. It's quite interesting. So imagine this is a dust particle. How this can be suspended in the air, you can see from here. Because the dust particles are more visible. Those are bigger than the air molecules. Air molecules are not visible to the naked eye, but dust particles are visible. So what does here is this molecules in the space, the air molecules, they are really moving, and when they move, these molecules hit this dust particle, or the dust particle is hit by the air molecule. So dust particle cannot come down because it's always being hit by air particles. Maybe later it will settle, but it can be airborne for a long time. So that's why once a dust particle is airborne, it takes time. Even the viruses, bacteria, mold, other than even the metal dust. Okay, there can be different nature of micron-sized particles. So all in the air, the reason is that air is a kind of a sea of molecules in motion. So there is no chance for getting escape these dust particles, virus and bacteria, not getting hit by the molecules, not possible. So it is airborne. That's why even the COVID becomes mostly the airborne disease because of this. The viruses, micron-like particles, you can consider as particles by this. So that's the situation. So this is how the particles are being suspended. Okay. Even more than one particle. It's the same. about this. Yeah, you can see. Actually, it's like this, moving randomly. We call this Brownian motion. Okay, we call this Brownian motion. Brownian means those motions are the distance and even the velocity side very small levels. Yeah, Brownian, the smaller Brownian means the motion of these tiny particles, and the motion because of these particles being hit by this air molecules. So having this knowledge, we can address a lot of things in thermodynamics and even the air filtration, designing of a mask, filters, okay. And there are a lot of solutions we can have when we have this level of imagination, okay. So you can imagine this one. And this is just a model of this. So that's why the wearing of mask is very important these days to avoid from COVID. The number one is this wearing of mask. Extremely important. So now imagine. So this is the case I want to share with you. It is not about dust. So this is we call the Brownian motion. And imagine this is a particle, you know. Imagine if this is a water droplet. Imagine a water droplet experiencing Brownian motion. A tiny water droplet. Because that's why even water, if you spray, it won't come down easily. Of course, big particles maybe, but a tiny water droplet. What happens is, this is the water droplet. This is the water droplet. So now I'm not talking about Brownian motion. Not only that, what happens is because of the Brownian effect, okay, on a tiny water droplet, because of the Brownian effect, two things. this droplet is airborne. So while this droplet is in the air, the water droplet getting energized. It receives energy because molecules hitting this water droplet. So heating makes the whatever molecule hit here, air molecule lost its energy because this hit, and the water molecule gained the energy. So water droplet is getting energized and turned into vapor. Because energy receiving, and finally this molecule so energized that water droplet molecules that they turned into vapor form, like steam, and turned into vapor. So what happens to air? Air lost energy and gets cooled. Air molecules lost energy to this water droplet and get cooled. So air molecules lost energy to the water molecules and get cooled. Can you understand now? So very interesting. Keep it. So this is what happens when a tiny water droplet adds into the air. So Brownian effect finally results this. Of course, for Brownian effect, you should know that it is for airborne matter. Particle no Brownian effect of a particle on your table, but this is airborne particles. Okay, good. Can you see how important this knowledge for you? Okay. Now let's say another one. Okay. A very important but unbelievable knowledge. So if we add steam into air, okay, not in big amounts, but steam into air, okay, not exceeding the holding capacity of moisture in air. Let's say only 50% of, let's say, not exceeding the holding capacity of moisture. So we are just not overpouring steam, but we are just let steam diffuse into air. Means if we let steam, 100 degrees Celsius, yeah, normally steam. If we let steam diffused into air, not to say diffuse, but I take this out. Steam we are adding. Surprisingly, no air temperature rise. Okay. If air temperature rise is there, that is negligible. Negligible means if air temperature rise is there, that is negligible, because it's like that. The reason is now you are adding steam droplet. So the steam droplet become harmonized with air energetically in quite easy manner. No energy interactions. But water droplet, yes. Steam droplet, no. Because steam droplet, so immediately harmonized with the air. So it becomes part of this moisture in air if we add moisture. So it becomes harmonized. Anything? Look, someone in a busy situation today. පුතා ඒ විදිහට නම් lectures අහලා මේ හරි අමාරුයි වැඩි කරගන්න. So you have to be a good focus on this. සින්දු අහන ගමන් මේක කරන්න බෑ මේ වැඩි. Okay. So this is very important, especially in air conditioning and all, to increase the humidity levels. Sometimes if you're adding steam, we may not know. So we should understand this. That's why steam baths are possible. Steam baths in sauna kila. So that's why steam baths are possible. එහෙම නැත්තම් මොකද වෙන්නේ? මේ පිච්චිලා යනවනේ අංශක 100 steam එක තියෙනකොට. No. That's why even steam baths are possible. තේරුණානේ? adding 100 degrees Celsius steam, but once mixed with the air, it's a different story. No significant temperature rise. Interesting. Because it is already in gas form, like in gas form. So no much of interactions. But if liquid, different case. Air molecules lose energy means air molecules lose energy means air temperature drops. So air temperature drops. So that is the point. Interesting. So this is you can understand this by understanding this Brownian effect. Okay. So Brownian motion and the Brownian effect. Yes. Very interesting. And let's say air absorbing water. An example, let's say sometimes what happens? See, sometimes the hot dry air sweeps or surfs the water here. Surfs the water. As a result, air absorbs not moisture, water, tiny water droplets. And what happens is the same situation I explained. The Brownian effect. While retaining these tiny water droplets for little longer time, there is an energy exchange, means transfer from air to water. Energy transfer. Energy transfer from air to water. There is an energy transfer. Energy transfer from air to water. Energy transfer. energy transfer here. Energy transfer. So energy transfer from air to water. Air to airborne water. Okay. Air to airborne water. Not on this reservoir or sea, but air to airborne water. As a result, the temperature drops. As a result, the temperature drops. Temperature of the air drops. So this is very important phenomena that you should understand. තේරුණානේ? මේ කටපාඩම් කරන ඒවා නෙවෙයි at least you have to imagine this, the possibility. So what takes place here is water evaporates within the air, and air get cooled. So water evaporates within the air and air get cooled. So that's the part. So there is a name for this: evaporate and cooling. We call this evaporative cooling. What? Air. But we just call evaporative cooling. Everyone knows. But this is really evaporative cooling of air. Okay. So this is a very good explanation. This is not in your one-day note, one-time note. So this is well explained here. Evaporative cooling. It is very important. That's why sometimes in the lakes and all, we like to be in the lake front and all. This is the reason. When the wind surfs here over the water, air absorbs water and evaporative cooling phenomena takes place, and you will experience a comfortable climate, comfortable air It's something like air condition. So this is the evaporative cooling phenomenon. So even to have a comfort climate, not indoors, even outdoors, we should preserve the lakes, water tanks, inland water bodies, marshy lands, paddy fields, even the forests supporting this we call catchment areas, forests supporting to have water retention in the lakes. It helps to have a reasonably cold weather in summer times. So it is very important for the nature to preserve these water bodies. So imagine if in the dry zone area, Anuradhapura and Polonnaru, North Central provinces, so this water bodies helps to have little bit cold climates, daytime, because winds are there flowing or surfing this water and makes the surrounding cold. It's very nice. The nature's phenomena. Even having the forests also may have a similar tiny effect on evaporative cooling. Other than that, the shades and when the wind flows through the forest, the temperatures are quite comfortable. Also related to these phenomena. That's why preserving the nature has climate connections as well. Not many are talking about managing local climates by preserving water bodies. So that is very important. Parts of thermodynamics. So thermodynamics can explain this. Now you know. So if you see unrepaired and the dry water tank, abundant water tank, not using it, not repaired, not reconstructed. Imagine if that can be constructed, not only for the irrigation, not only for agriculture, but it's a blessing for the surrounding. That's why wherever waterfronts, those are popular. Example, Kandy city, there is a lake. Kandy is populous. Anuradhapura, Polonnaru cities, there are lakes, populous. Colombo waterfronts, Bear Lake and all. Even in the Javardhanapur area, there are a lot of water bodies, marshy lands, populous, but you feel quite okay to be at waterfronts. You can see even the Gulf is the same effect. The nature's gift of this phenomena really makes people comfortable to be there. That's why we should preserve this. Inland water bodies. Even in front of a paddy field, with well-grown paddy, of course, you can see the effect. Not during the harvesting, but in the green, when the paddy fields are greenish, what is there? The wind really helps. Wonderful. So you should have understand of this. It is very important. Okay. So even for climate cooling, indoor cooling, for green buildings, I think that is for BST and all. So to have a comfortable surroundings plus the green building solutions, evaporative cooling technology is what working for you all. So adapting this nature's phenomena for our good use. We should know this phenomena upfront. If not, we are working blindly. Okay. So it is very important to look into this. Okay. And even now, the technologies brings the lake to your home garden. How? The technologies bring the lakes to your home garden. How is it? How? What makes it possible? What makes it possible? Be in the home garden, but something like be in the front of a lake. So there could be commercial scale solutions. Yeah, you have seen this. See, technologies, very simple. Fan and the spray of tiny water droplets, not the water vapor, but tiny mist. Mist means water droplets. So that this evaporates and brings the surrounding cool. So actually you can develop this kind of things. So it is like being in front of a lake. So those who have not far, not lakes nearby, your climate is an issue. So you have the solutions, and this nature of solutions are now popular in the markets. Even indoors, outdoors, okay? And even the centralized solutions, you can see this nature of products, applications. Because climate, comfortable climate is important for humans as well as for the creatures. But the point is this: you can have some sort of comfortable climate having these gadgets, but imagine there are other animals, creatures in the nature. They also need comfortable living. So if we destroy the forest, if we are not taking care of the water resources and the water tanks and all, the climates, especially during summertime, will be tough for the other creatures. So if you take care of these for the others, that is the assurance for us to have a good climate. It is not to have an aircon for you, but to have good climate condition in the nature so that we can have the same what the others creatures are enjoying. That is very important. But if we need solution situational, we can have this nature of applications as well. Evaporative cooling. So this is to be done with this phenomena, and if you have a very good sense and understanding about moisture in air, so you may have this nature of applications. Very nice. Okay, very nice. And in the appliances, it's I think appliances like this maybe. Or copy. Inside, you may see the same, the hot air sweeping over this water, the wetted media, and this air absorbs water and the cold air comes out. It's the same. So you are doing this using your technology, it's the same. But the best is still this. Okay. So nature, we have to take care. This is only for you indoors maybe, or for the functions, but this is for all the creatures. So that is very important. Environmental sustainability is the number one. Even to understand that, knowledge of thermodynamics is important. Now, even if you see a barren paddy field or abundant water tank, or even forest or a land piece seems very dry with no tree or anything. So you feel how sad to have that kind of situations. Rather, we should have this nature's gifts to be effective everywhere. That is very important. Okay. So that's the lesson today for your Independence Day. Okay. So as long as our environment is not taken care, don't expect any independence. True independence, not possible. Yeah. So the more we are naturally gifted, the environment and resources are, and if all the creatures have the privilege to enjoy their life with the gifted environment and the resources while preserving resources for the future generations. So as long as if we have that, every day is an independent day for us. Till then, no independence. So even the Independence Day, think deeply what that means. Are we really have that? And give a meaning for that day. I think in that point, we met here today, learn something, and this is an additional gift of knowledge for you from today. So you should feel good joining the class. 12. So hope to see you in this coming Wednesday, if possible, Putala. There are a little bit to complete on today's sessions. SFEE and even this evaporative cooling, the nature's phenomena. You can send the attendance now. Send me the attendance. I will save all. So if you get something out of today's class, I think it's very good. So I will email this to you today note, daily note, and also I will upload the video. Please go through all and don't forget your one-time note. Extremely important. So thanks for being patient till the end of the class to send the attendance. Yeah. So we are about to complete our thermodynamics knowledge, because once you understand it step by step methodically, no big deal. Then later we can go for analysis, nothing. Okay. So if you feel thermodynamics difficult, I think that is something wrong. Okay. One of the easiest. But the point is thermodynamics. You need to see this through your mind. That is very important. So the product you are seeing here is not thermodynamics, but the phenomena takes place here. That is thermodynamics. Okay. So I believe wonderful knowledge sharing today. February 4th, motion. We talk a bit. So we will need to talk a little more to have some very useful analytical parameters, something like relative humidity and all. Later we will talk about this. So steady flow energy equation, insight, we have done both insight to steady flow energy equation and moisture in air from the last week's slides from lesson 4. So that's why you should go through this and understand. And also you have to get this knowledge connected with your one-time note I passed you early. And then some analysis. W compression. Compression work should be minimal. And for the stationary turbines, the net output should be maximum. For aircrafts, the net output should be optimal, because there is a nozzle component for a thrust. So aircraft or a reciprocating engine, piston cylinder, the same thermodynamics processes takes place: intake, compression, power, exhaust, plus the combustion. Taking component by component. Energy balance. We took W as H2 minus H1 for compressors. Combustion chambers, we took this. We learned that. This I knew one day note as well. You have noticed that. So this is your part. And is connected with today knowledge sharing about turbine. You have this, energy balances. See how simple are these if you have some practical sense lying underneath this evaluations. So if you have a heat rejection, possible. This. Then nozzle. It's very strange because no components inside. See the tree and the coconut. The gravitational potential energy, mgh. But later we change mgh to mgz. See, z, mgz. And your kinetic energies, plus U plus PV. So U plus PV is very important. And the potential and kinetic. We came to this formulations. Inlet condition 4 and outlet 5. So inlet energy minus the heat loss is the outlet. So there we can have a formulation for this thermodynamic formulation, steady flow energy equation or the energy balance for the nozzle, flowing of working fluid through the nozzle, can get it. Then we had a break. After break, the motion, Brownian motions, Brownian effect, and then air absorbs water. We know that. As a result, evaporative cooling phenomena takes place. We know how important this for nature. And if we don't respect and preserve this effect else everywhere, we will be facing issues. But artificially, we can have this technology. So don't think technology is only this, whatever we make, no. The nature's phenomena understand. The nature has its own technology. We have to understand those, we have to maintain and we have to improve those also technology. So the irrigation engineers, water resource managers and all, if they know thermodynamics or the nature's phenomena, sure they are doing something exceptional. That is very important because a drop of water also has a value for the nature. Water is not only for irrigation and power generation. It's a nature's need. Good. Your possibilities of innovations and manufacturing. So you have future projects. You have the design capabilities. Dream and imagine these simple products. Still we are importing. Very funny. So see how we can make this. Quite interesting. Okay. Quite interesting. So that's all, Buddha. Thanks for joining the session today. Would be very useful. So we will continue in the coming weeks. So any more comments, anything before winding up? Okay then. So thanks for being in the class today, even though it's a holiday. Not a holiday, it's an independent day. So we gave a meaning for this day today. So that's all from my side then. So I'm going to stop the class. COVID is around, so take care. Yes, you know Brownian effect. So the solution for COVID prevention, I think Brownian effect plays a big role, Brownian motions and all. So good. See you next week then. Bye, Putana. Bye.
Thank you, sir.
Thank you, Putana.
Thank you, sir.
Bye.
Thank you,
Thank you, sir.
sir.
Bye.